In this lecture, we are going to understand one important concept, that is writing inline assembly code. The inline assembly code is used to write pure assembly code inside a C program. Basically, we use inline assembly code in order to access the processor core registers such as general purpose registers or special registers or the stack pointers. If there is any way by which you can access those registers is using inline assembly code. To use inline assembly code, you have to follow the compiler's inline assembly syntax. That is very important because different compilers have different syntaxes. GCC has one kind of syntax, ARM compiler has one kind of syntax, and the syntax on ARM compiler may be different. Let's see an example. Let's say you have an instruction move r, r1. This is an instruction. If you want to include this instruction inside a C program, then you have to use the syntax of the inline assembly, which is given by the ARM GCC. This is how we write it. First, the inline assembly statement should start with a keyword called __ASM, or you can omit this __, and you can just write ASM, no problem. And after that, this is an optional type qualifier volatile. After that, you have to write your instruction inside a parenthesis and inside the double quotes, and you have to terminate the inline assembly statement with a semicolon. That's the syntax used by the ARM GCC compiler. Let's see one more example. Let's say here I have a couple of instructions. This is a load instruction, this is the add instruction, and this is a store instruction. Basically what these instructions do is this is a memory read instruction, and this is a modify instruction where we add two numbers, and after that this is a store instruction, read, modify, store. If you want to include these instructions in a C function, let's say, then you have to write like this using inline assembly syntax of the GCC compiler. Instead of using 4 separate inline assembly statements, you can do it in one using a syntax something like this. You can finish it off in only one statement, but every instruction you have to cover in double quotes. That instruction should be terminated by /n and /t. Just observe that there is no comma. Just include every instruction inside the double quotes and terminate it by /n and /t. This syntax also valid. Or for simplicity, you can use this. First of all, let's see why would you use inline assembly code in a C program. Consider a situation where you want to move the content of a C variable data to ARM register R0. So how do you do this? You can't do this using pure C statements. You have to use inline assembly code. Just imagine a situation in which you want to move the content of the control register to the C variable control reg. How do you do this without using inline assembly code? That's not possible, isn't it? These are the occasions in which we have to use inline assembly code inside the C program. Let's explore the general format of the inline assembly statement of the ARM GCC compiler. This is a general format of an inline assembly statement. Remember that this format applies only to the ARM GCC compiler. This format may be different if you move to different compilers such as ARM CC or IAR. As I said, every inline assembly statement must start with a keyword ASM or __, ASM. And after that, this volatile attribute is used to instruct the compiler not to optimize the assembler code. Sometimes what happens is when you enable the optimization, then compiler may optimize the code what you have included here. If you don't want compiler to do any optimization on your inline assembly code, then use the volatile. After that, assembly mnemonics you have to mention here. So the example we saw in the previous slide, isn't it? Apart from assembly mnemonics, it has three other parts, what we call as operand list and a clubber list. In the operand list, there are two types of operands, output operand and input operand. If you have any output operands, you have to mention that inside this block. This is the output operand block, and you can mention list of output operands separated by commas here, and it will always follow right after the code section or code block. You have to separate these blocks using colons. These are important, colons. Input operand list follows output operand list. Here you can list a couple of input operands separated by commas. Clubber list follows input operand list, and the clubber list is mainly used to tell the compiler about modifications done by the assembler code. In the upcoming lectures, we'll understand how to use all these sections. Let's say I have only code block. In the previous slide, we saw this instruction, move r, r1. This is an example of inline assembly code which has only code block. There is no output operand, input operand, or the clubber list. That's the reason you can write something like this. It doesn't have any operand list or the clubber list. Or you can also write like this. This implies that there is no output operand, no input operand, and no clubber list. That's why colon, colon, colon. Both are same. Let's do an exercise to use these inline assembly statements in the C program. I'll see you in the next lecture.